Hashing passwords can be complicated. There are algorithms, salts, hashes, and other terms involved. And it should all be secure. Today, I will explain what BCrypt is, when to use it, and how to use it in your .NET applications. Hi, I'm a software engineer with over a decade of experience with the .NET platform, and on this channel, you'll learn all about .NET development. Before we learn more about BCrypt, let's quickly talk about that. If you can avoid storing passwords at all, you should definitely avoid it. One of the advantages is that what you don't have, you can't lose. In most situations, it makes sense to use one of the established authentication providers such as Microsoft Active Directory, Auth0, Identity Server, or any other of those products. Okay, let's say you have to store passwords and you absolutely cannot use one of the established authentication providers. The most important rule is that we should never ever store plain text passwords. If someone gets access to your database, they now have all the username and password combinations. And imagine a user uses the same password on your service and another service. Never do that. So, what's the alternative? The alternative is to use a hashing algorithm. A hashing algorithm turns an input string into a hash. Hashing uses a one-way operation, meaning that turning an input into a hash is very simple, but a hash cannot be turned again into its input form. Well, never say never, but at least it's very hard to get from a hash back to its original value. If you, for whatever reason, cannot choose one of the established authentication providers, BCrypt is a great option. Let's quickly learn what BCrypt is and how it works. After that, we will write code for a .NET application using BCrypt. BCrypt is a password hashing algorithm based on the Blowfish cipher and was first released in 1999. It uses a salt to protect against rainbow table attacks and is adaptive. Adaptive means that over time we can increase the number of iterations used for creating hashes. We can account for increased hardware processing power. That's enough theory for now. Let's jump into Visual Studio. I created a new console application. First, we need to install the bcrypt.net-next NuGet package containing the BCrypt implementation for .NET. Now, let's start by defining a password variable. We assign secret password as its value. Next, we define another string variable that will contain the hashed password shortly. We use the BCrypt class within the bcrypt.net namespace. There is a naming clash because the namespace and the class are both called BCrypt. I will show you later how to fix it in .NET 6 and newer programs. But let's move on by calling the enhanced hash password method. As the first method argument, we provide our password. As the second argument, we provide a work factor. The work factor is a number that indicates the level of how many iterations will be performed when calculating the hash. As discussed earlier, BCrypt is adaptive. We can set a work factor and change it in the future. The default work factor currently is 11. For one of my applications, I currently use 13 as the work factor. 13 is a great mix between security and duration. For example, generating a single hash takes about 800 milliseconds on my computer. It means that trying 10 different passwords will take about 8 seconds, making it very slow for a potential attacker. On the GitHub page, you'll see a table that lists the work factor and its associated number of iterations. Work factor 11 uses 2048 iterations, while work factor 13 uses 8192 iterations. So, in simple terms, by adding 1 to the work factor, we cause double the iterations. That's enough talking about the work factor. Next, we print the generated hash to the console. Let's start the program and take a look at the generated hash. The hash contains 60 characters and starts with an information block before the actual password hash. The 13 we can see equals to the work factor we used to generate the password hash. It allows us to later increase the work factor for new passwords, but still be able to verify the hashes of passwords created with a different work factor. One thing to mention here is that the hash also contains a salt. We can see that if we restart the application, we get an entirely different hash, although we use the same password to generate the string. The salt being part of the hash means that we cannot hash a user input and compare it with a previously generated hash to find out if the user input was correct. Instead, we need to use the verify enhanced method and provide the user input as well as the stored hash. Let's add another console.writeLine method call that prints whether the input is correct. We use the enhanced verify method of BCrypt and provide the user input as the first and the password hash as the second argument. Let's start the program. As you can see, it prints true as expected. We provided the same password for the generation of the hash as well as the verification. Now, let's alter the input for the enhanced verify method. When we start the program again, we see false, meaning the password verification detected that the user input doesn't match the input used to generate the hash. The salt being part of the hashed password might be a little confusing at first, especially if you previously used different algorithms and had to use salts yourself. Personally, I like how BCrypt uses salting. It's very simple to use and BCrypt prevents you from forgetting about salting. If you, for whatever reason, want to have more control over the salt generation, you can use the generate salt method and provide the salt to the enhanced hash password method. See the documentation for more details on that. As discussed earlier, the fact that BCrypt is the name of the namespace and the name of the class is unfortunate. However, with .NET 6 and newer, we can resolve the issue with a simple line in the project file. We add a using definition and provide an alias for the namespace. We can now change the code and use the alias to call the static methods enhanced hash password and enhanced verify. Let's quickly summarize what we learned today. Whenever possible, we should use one of the existing established authentication providers. If we cannot do that, we should make sure to use proper hashing and never ever store plaintext passwords. BCrypt offers an adaptable algorithm, and the BCrypt NuGet package offers a simple implementation for the .NET platform. The fact that the salt and the work factor are both part of the generated hash makes it simple and secure to use BCrypt to hash your passwords for .NET applications. Please don't forget to like and subscribe if you haven't already, and I'll see you in the next video.